This video segment includes 5 short demonstration videos of various features of the Trax tool. The first is the Equations tab. This is the tab where you may select from standard functions and relations in both rectangular and polar form. You can change various equation settings, or you may also create an equation of your own. The output includes a graph, text description, and sound. Let's take a look at the demonstration video. Welcome to Trax. To graph an equation, select the Equations tab at the top of the Trax screen. Enter an equation or select an equation from the drop-down selection menu. This demo shows a user selecting an equation from the drop-down menu. Once an equation is selected, Trax provides a textual description accompanied by a graph. You can change the parameters of the graph by typing in a new value in the variable text boxes. The demo shows the parameter value for C has been changed from 1 to 3. To redraw the graph and update the text description, click the Draw button at the bottom center of the Trax window. To hear the equation, click the Play button at the bottom left of the application. The Data tab allows you to select your own data table for input. You should include a header row to describe each column, and columns should be separated with tabs, commas, or blanks. Also remember that the first column of your data should be in numeric order and evenly spaced. The first column is the independent variable. Subsequent columns are dependent variables and can each be graphed together or individually. This tab also outputs both a graph and text description. Let's see how it works. Type the path and name of your file or browse for the file by clicking on the Browse button. Select a file that was created using a text editor or Excel spreadsheet and contains column-separated numeric data with text headings. This demo shows the user selecting the full data file. Select the file and click Open. The file loads with the path and name of the file, the selectable headings, and a table of numeric data. This file opens with the plot for acceleration. The demo shows the user selecting the light heading. Note that Trax now shows the plot for the light information in the graph and also in the graph description area. The user now selects the pressure heading. Note the new information in the graph and description areas. To hear this graph, click the Play button at the bottom left of the application. The Trax website has 2 additional demonstration videos to explore various polar equations and how Trax can be used to better understand the concept of slope. If you're interested in viewing these videos, they're available as excerpts in the Teacher Video Collection on the NES Virtual Campus. The Physics tab includes both a roller coaster and rocket simulator, both of which help students understand the relationship between math equations and their application in the real world. The roller coaster simulator allows students to build a simulated roller coaster track using a mathematical equation to model the shape of the track. They can then set initial position, initial velocity, and manipulate gravity and friction to try to get the point or the roller coaster car from its starting point to the end of the track, or the rightmost bound. They can watch, listen, and read the description and try again if unsuccessful. Let me show you how it works. During the roller coaster simulator, you might consider setting your own parameters or requirements in order to change the difficulty level, or perhaps focus on a specific concept like x-intercepts, max or minimum values, a particular type of function, or maybe gravity and friction. Let me enter a trigonometric function. Your students can manipulate A and B, or the initial position, friction, speed, and gravity in order to try to make a successful run. Let's go ahead and change the initial speed of this roller coaster to 5 units per second and start the coaster. Good job, we had a successful run. Your students can read through this text description and find out more information about the physics that are involved in this roller coaster run. And in fact, towards the end of the text description, there's a summary of test run results. You can copy and paste this data into a spreadsheet and load that data into Trax so that you have a graph comparing such things like speed of that graph related to time. You can also print the graphs and print the descriptions or save them as PDFs so that your students have evidence of their different trials. They're able to turn this in for homework or perhaps use it as they share this information with other students during class discussions. The rocket simulator allows students to explore the graphs of acceleration, altitude, drag, flight angle, range, and velocity as a function of time for a rocket launch. They may alter the initial parameters for the rocket and then see how the change affects the rocket's trajectory or flight path. Let's take a look at a simulated launch and see how mathematics applies to rocketry. I would recommend that your students initially launch their rocket with the default settings. You might want to discuss with them each of the terms that you see here, or perhaps focus on just one or two of the terms. For example, let's take a look at altitude versus time. Your students can then discuss what they see during a launch versus what they see compared to the graph. We can do the same thing for velocity, acceleration, or even range. Then we'll go back to the initial launch settings, and your students are going to change one parameter at a time, and they can change it multiple times to see how that parameter would affect the outcome or the flight result. For example, let's take a look at launch angle. If your students change the launch angle, and then they launch their rocket again, they can go back and see how that impacts the acceleration, how it impacts the range, the velocity, and so on. So by the end of the lesson, the students could conclude the launch angle that provides the maximum distance or range. This type of a lesson could be used in a physics class to talk about forces in motion, or in calculus to look at derivatives. You could even collect data from a model rocketry website so that the students could look at how modeling can be used by scientists and engineers to help predict what would happen during an actual launch.